Hello students, this is the second class of the lesson Electricity. In this class we are going to learn electric potential and potential difference, relation between potential difference and electric current, Ohm's law and resistance. Students, in the last class we saw that how electric charges flow and constitute electric current. What makes these electric charges flow? I think your answer is battery. Yes, battery exerts pressure on the electric charges to move. That's right, but how does battery exert pressure? How this pressure is generated in the battery? What happens inside the battery? Come, let's learn more about it. See these pictures here. In the first picture, you can see water flowing from higher level to lower level. It happens due to gravity. Do charges also flow from higher level to lower level due to gravity? No. For the flow of charges in a conductor, gravity has no role to play. Charges are not affected by gravity. Now, see the second picture. Here, two tanks with different amount of water are connected with the pipe. Tank 1 has higher amount of water and thus higher potential, whereas tank 2 has lower amount of water and thus lower potential. This difference in the potential creates a pressure difference between the two ends of the pipe such that water flows from higher pressure to lower pressure. That is from tank 1 to tank 2. Now look at the third picture. Here both tanks have equal amount of water, thus equal potential, and as a result equal pressure at both the ends of the pipe. And as there is no pressure difference between the ends, water does not flow through the pipe. Students, what did we understand from this? We understood that water flows through the pipe only where there is pressure difference between the ends. Similarly, the electrons move only if there is a difference of electric pressure along the conductor. This difference of electric pressure is called potential difference. This potential difference is produced by the battery consisting of one or more electric cells. The chemical action within the cell generates the potential difference across the terminals of the cell. When the cell is connected in a circuit, the potential difference sets the charges in motion in the conductor and produces an electric current. Electric potential difference is the work done to move a unit charge from one point to the other. We can also write potential difference between 2 points is equal to work done by charge, or V is equal to W by Q. SI unit of potential difference is volt. We say that potential difference is 1 volt when 1 joule of work is done to move a charge of 1 coulomb from one point to the other. That is, 1 volt is equal to 1 joule per 1 coulomb. Or it can also be written like this. The potential difference is measured by an instrument called voltmeter. Voltmeter is always connected in parallel across the points between which the potential difference is to be measured. Do you know why voltmeter is connected in parallel? Because voltmeter usually has a high resistance so that it takes negligible current from the circuit when connected in parallel. But if it is connected in series, it may obstruct the flow of electric current due to its high resistance. Now, see these circuits and tell me Which one of the following is correct and why? Also tell me what happens if we connect ammeter in parallel and voltmeter in series. Leave your answers in the comment box below. And students, I have made a separate and detailed video on connecting ammeter and voltmeter in a circuit. I have inserted the link at the end of this video. You can click on the link to watch it. Also, I have provided the video link in the description box. Okay children, let's move on. Circuit diagram. You know that an electric circuit comprises a cell, a plug key, electrical components and connecting wires. It is often convenient to draw a schematic diagram in which different components are represented by the symbols. Conventional symbols used to represent some of the most commonly used electrical components are given in this table. Go through this table and practice. So far we have discussed about electric current and potential difference. What do you think? Is there any relationship between these two? Come, let's do an activity and explore it. Students, in this activity, I am changing the number of cells used in the circuit and noting the values of the current I and potential difference V. See, our circuit is ready. I have connected an ammeter in series to measure the current and a voltmeter in parallel to measure the potential difference. Here is the table to write the values of I and V. First, let's note down the values of I and V for one cell. Here, I is equal to 0.9 ampere and V is equal to 9 volts. Then two cells. Here I is equal to 1.8 and V is equal to 18. Then three cells. I is equal to 2.7 and V is equal to 27. Four cells. I is equal to 3.6 and V is equal to 36. Then 5 cells. I is equal to 4.5 and V is equal to 45. Now, write the ratio V by I in the table. What did you get? Yes, we got V by I is equal to 10 in all 5 cases. That means V by I is a constant here. If we plot V by I graph for these values, the graph will look like this. This straight line shows that as the current through the wire increases, the potential difference across the wire increases linearly. From this activity, we can conclude that the potential difference V across the ends of a given conductor in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. This is called Ohm's law. In other words, V is directly proportional to I, or V by I is a constant. This constant is represented by the letter R. R is a constant for the given metallic wire at a given temperature and is called its resistance. It is the property of a conductor to resist the flow of charges through it. See this picture? Here this is the electric current, this is the potential difference and this is the resistance of a conductor. Resistance in a conductor obstructs the flow of electric current. SI unit of resistance is ohm and it is denoted by this Greek letter. If a potential difference across the two ends of a conductor is 1 volt and the current through it is 1 ampere, then the resistance R of the conductor is said to be 1 ohm. That is 1 ohm is equal to 1 volt by 1 ampere. Or we can also write like this. Using the relation R is equal to V by I, we can also write I is equal to V by R and V is equal to IR. It is obvious from this equation that the current through a conductor is inversely proportional to its resistance. If the resistance is increased, the current gets decreased. Students, in many practical cases, it is necessary to increase or decrease the current in an electric circuit. In such cases, a device called rheostat is often used to change the resistance in the circuit, which in turn changes the amount of current in the circuit. Now let's see how does resistance work in different materials. We know that some materials allow electric current through them and some do not. Certain components offer an easy path for the flow of electric current while the others resist the flow. Electrons are restrained by the attraction of the atoms among which they move. And the motion of electrons through a conductor is retarded by this resistance. This resistance decides whether the material is an electric conductor or not. By knowing the resistance of a material, we can decide that whether the material is a good conductor or resistor or poor conductor or insulator. A component of a given size that offers a low resistance is a good conductor. A conductor having some appreciable amount of resistance is called a resistor. A component of identical size that offers a higher resistance is a poor conductor. An insulator of the same size offers even higher resistance. Students, here I am inserting a link of the video on how certain factors modulate the resistance of a conductor. Watch this video before moving. Okay students, now let's list the factors on which the resistance of a conductor depends. Resistance of a uniform metallic conductor is directly proportional to the length of the conductor. As the length of the conductor increases, resistance also increases. On the other hand, as the length of the conductor decreases, resistance also decreases. Then, this resistance is inversely proportional to the area of cross section. As the relation between the resistance and the area of cross section is inverse, if the metallic conductor is thicker, then the resistance is less. And resistance is directly proportional to the temperature. If the temperature is high, then the resistance will also be higher. Then, the resistance of a uniform metallic conductor depends on the nature of the material. The structure of the materials decide whether the material offers high resistance or least resistance. Okay children, that's all for today. Now answer these questions and check your understanding.
To watch more such videos, please subscribe my channel.